So, in the past chapter, we talked about functions in mathematics. And so, a function is named according to its equations, according to its equation. So, for instance, let's say we have the equation y equals 3x plus 7. So, this function is called a linear function. Now, the reason we call it a linear function is because y is a linear polynomial of in the variable x. So it is a polynomial in the first degree, so we say that it is a linear polynomial of the variable x. So basically, a linear function is a function whose general equation is going to be y equals mx plus b, where m and b are constants, but m cannot equal 0. Now the reason it can't equal 0 is, let's say if we have the equation y equals 0 x plus 2, then really we just have y equals 2. And now this is not a linear function because it's a 0-degree polynomial, so it's a constant function. So now we're just going to look at a couple graphs of different linear functions. So to start, we're going to have the graph y equals 3x plus 7. So we're going to start off by making a table of values x and y, and we're going to plug in different values of x and see what values of y we're going to get. So if we plug in x equals 0, we're going to get 7. If we plug in x equals 1, we're going to get 3 plus 7, which is 10. 2, we're going to get 6 plus 7, so which is going to be 13. And if we plug in 3, we're going to get 9 plus 7, which is going to be 16. And if we plug in negative values of x, such as negative 1, we're going to be getting, it's going to be negative 3 plus 7, which is 4. And if we plug in negative 2, it's going to be negative 6 plus 7, which is going to be positive 1. So now looking at these values of y for when x is increased by an increment of 1, we're seeing that it's rising by 3 units in the y direction. So when x increases from 0 to 1, goes from 7 to 10, so that's 3 units right here. Here's another one, it goes from 13. And below negative 1, below 0 is negative 1, and 3 units less than 7 is 4. So it's increasing linearly, meaning that it's increasing by the same amount for each increase in the x. So for that reason, we say that the slope is 3. Slope is rise over run, so as x increases by 1, it's going to be increases horizontally by 1, the function is going to be increasing vertically by 3. So that's why the slope is 3. For that reason, we know that the m variable in y equals mx plus b is going to be the slope, and the b variable, which in this case is 7, is going to be the y-intercept, because the y-intercept is when it crosses the y-axis, or when x equals 0, and when we plugged in x equals 0, we get 7 for y. So now graphing this equation, we can whoops, it's going to be more like this. We can both plot these points in the table and look at both the slope and the y-intercept from the original function to draw the graph. So 0 is going to get us 7, which is going to be up here. 1 is going to be 10. 2 is going to be 13. 3, 16. And we know it's increasing by, we're saying this is 3 units vertically and 1 unit horizontally. And at negative 1, it's going to be getting 4, which is about here. And negative 2 will be about here. So we're going to be getting this linear function. And the slope of this function is going to be equal 3, because Slope is the change in y over the change in x, so the change in y from 0 to 1 is going to be 10 minus 7 over, here, m equals 10 minus 7 over the change in x, which is going to be 1 minus 0, so which is going to be 3. So this concludes the introduction unit to chapter 3, which is on linear functions. So in the next unit, we're going to be looking at specific linear functions and what information is given by their equation and how we can draw those graphs without plotting individual points. Okay.